Hello everyone, welcome to my channel. So in the last video we talked about why do we need multi-threading and how can we create a thread using thread class. So the link to the last video, I'll post it in the description. If you haven't seen that yet, I would recommend take a look at that first and then continue with this video. In this video we are going to talk about how can we implement or how can we create a thread using a runnable interface. And we'll also briefly talk about the pros and cons of the two approaches, whether to extend a thread class or to actually implement a runnable interface. Let's dive in. So let's first see how can we create a runnable class. So before I go in there, so we already have a student service here which has a method called saveStudent which accepts this student object, and then it sleeps for a second and then it prints out a statement and it returns back a student ID. So the student object is nothing but a plain simple Java object which has just one field called student name here. That's it. So this is how you actually create a runnable. As you can see, we are implementing the runnable interface here. And then this has a constructor which takes two objects, the student and the student service object. And we override the run method. And in the run method, we call student service dot save student. And if you take a look at the runnable interface here, this is a functional interface. So as you may know, functional interface is an interface which has just one abstract method in it, and which is the run method, and this is the method we override in the student runnable class here. And now going back to see how we can call this, so let's take a look. So first let's create student service class and the student object. Student service equals new student service. And we'll also create a student object. This accepts a name, so we'll just give a test name to it. Now we created the instances of student service and student. Now let's see how we can create a runnable object. It's pretty simple. Just say student runnable equals new student runnable. And then we need to pass the student and the student service that we just created. And now let's create a thread. New thread, and then to this thread we'll pass the runnable object. And after that we just call thread.start. This should call the run method within this runnable object, and then it should print this line and it should call student service dot save student. If we want to wait for this thread to complete, we can call thread.join method here. As you can see, it is complaining because there is an interrupted exception that we haven't handled, so we can just surround it with a try catch block here. Alright. So this thread.join will actually force the main method to wait for this thread that we have created for it to run to completion, and after that it will proceed to the other lines in the main class. So if you want to test that out, you can simply print a statement here saying system.out.println completed runnable. Just something to verify whether the main thread has actually waited for the runnable thread or not. Alright, so now let's run this and see. So as you can see, it printed the name of the current thread. So this is coming from the student service in here. So it says saving student, and then saving student is completed. It waited for the thread to complete, and then it printed here saying completed runnable. So that's it. So it is pretty simple, and this is the name of the first statement that it printed here. So it is coming from the run method within the student runnable. So there is an easy way to actually create a runnable object. We don't have to have a separate class for it. So let's see how we can do it. So we can actually create an anonymous class. For that, let's comment this out. Instead, what we can do is we can create new runnable, and in here we just have to say student service dot save student and student. So this would again should give you the same output as well. See that? So it spin off a thread. It says saving student. It waited for a second. It completed it, and then completed runnable is printed out. So this is until Java 7, but in Java 8 we have access to Lambda expressions. So let's see how we can simplify it even more with the Lambda expression. So all that you need to do is take out everything that you have here, and then you can just say student service dot save student, and then that's it. So let's run this and see if it works. See, it is exactly the same behavior again. The thread that we have created, it has first run to completion, and then we waited for it to run to completion, and then we printed out a statement before the main thread finished its execution. So this is how you create a thread in Java using a runnable interface. Now let's go back to this point on whether is it a good practice to extend a thread class, or is it better to implement runnable interface. So if you extend thread class, so that means you cannot extend any other classes, because Java does not allow multiple inheritance. That is one drawback of it. And the second way to look at it is that you have to, if you are inheriting from a parent, ideally you want to extend its behavior, right? But in this case you're not really doing that. What you're doing is you're just overriding the run method. So it's not really a good practice to extend thread. Rather, if you implement runnable interface, that would give you a possibility of extending that class with any other class that you want to. Like, you can still extend some other class and you can actually implement a runnable interface as well. So that is the advantage of using a runnable interface. So that is all I have in this session. In the next video, we will talk about the executor framework, and then the variants that we have in creating a different kind of thread pools. Thank you very much. Please let me know if you have any suggestions or questions. I would be happy to answer them. Thank you. Please do share and subscribe.